Alright, so, hey, it's 10:13 here in Mr. Bywater's 6th period class. Okay, hey, we've been in the land of congruent shapes. We're moving into the land of similar shapes, similar figures. So, congruency, we've already kind of gone over this quite a bit, but hey, same shape and same size. These are our congruent figures. Similar figures are different because, well, similar figures are the same shape, but different size. Okay, same shape, different size. Here's an example of two similar triangles. And I think it's helpful for us to review the terms corresponding sides, and corresponding angles. So, got fancy with some colors here. I don't know if you can tell the difference between the two different shades of pink that I'm using right here. But, hey, side AB. Corresponding side. Corresponding is fancy talk for the matching side in the other similar slash and or congruent figure. But we're looking at DE here. AB and DE are corresponding sides. And I know what you're thinking. You're thinking, well, Mr. Bywater, aren't there other pairs of corresponding sides? And to you I say, yes, there is. BC, for example, I could say that, well, its matching side is EF over here. Okay? And there's some helpful symbols that we use when we're talking about things like this, especially with similar figures and setting up proportions and ratios. I'll do something like this. Okay? With similar figures, the ratio of the corresponding sides, they are proportional, they are equal. So I can see that, hey, if I'm talking about side AB, well, I'm just going to write AB like that. That means I'm talking about the distance from A to B. So my other set of corresponding sides, I got BC. Let's go ahead and write that in there. BC is equal to EF. EF. And lastly, I have this other the bottom side here. These are corresponding sides. It looks like we have AC, and DF. And folks, one little thing I'm going to point out. Hey, notice I was consistent as to which triangle I put in the numerator. AB, BC, AC. These are the corresponding sides from this triangle. I need to be consistent where I'm putting the numerator versus the denominator. So we need to be consistent there. Okay, with similar figures, their angles, all the angles are all congruent. So there's a fancy symbol we use for congruent. It looks like this. I could say, hey, the corresponding angles A and D, these matching angles, angle A, this is my symbol for angle if I'm talking about an angle. And I'm going to use this equals sign with a squiggle on top to denote congruency. So I'm saying that the corresponding angles are congruent. Angle A, angle D right there. And yeah, there's certainly two other pairs of congruent angles. I could say, hey, angle B and angle E, these are congruent. And I think I'm going to run out of space here, but I could also say angle C and angle F, those are also congruent. Okay. And then if I want to communicate the fact that two figures are similar, figures if with a triangle it's nice because I can actually just put a triangle and say, hey, triangle A, B, C, and I use just this squiggle to say that two figures are similar. I'm going to use that little squiggle to tell you that triangle ABC and triangle DEF are similar. Okay. All right. So now I have an example question for us. Which rectangle is similar to figure A? And maybe I'll do it this way, actually. We'll look at a blank guy here. Here's how I'm going to figure this kind of thing out. If they're similar, then the ratio of the corresponding sides are proportional. They're equal. So I can do something like this. I'm going to say, hey, those are my corresponding sides there. So I should be able to do something like, well, 6 is to 6. And then my other set of corresponding sides, right here, 3 and 2. 6 is 3 is the 2. Sometimes I think of this as like, hey, long side is to long side as short side is to short side. Set up a proportion. Now I should be able to cross multiply these guys. And it turns out that I did do that already, so let's go back to my nice looking one. Okay, setting up a proportion. You can see I color coded it nicely for you. Setting up your proportion using the ratio of the corresponding sides. Cross multiplying, 6 times 2 is 12. 6 times 3 is 18. This is not true. These are not equal, so these two shapes are not similar. Okay, these two shapes are not similar. Now I want to actually check this rectangle C. I want to see if A and C are similar. So once again, I'm going to set up a proportion using the ratio of the corresponding sides. I'm going to say 6 is to 4, so bottom side is to bottom side. 6 is to 4, as short side is to short side, as 3 is to 2. Okay, so bottom sides are corresponding, and then the sides on the right are corresponding in this case. Okay, set up a proportion that looks like that. Now I got to cross multiply to see if these ratios are in fact equal, and 6 times 2 is 12, 4 times 3 is 12, so yes. This means yes. Rectangle A and rectangle C are similar. Okay. Okay, moving down to this bottom one here. This time I'm told that the triangles are similar, so I know that the ratio of the corresponding sides are proportional. So I can set up a proportion. Hey, corresponding sides, 6 is to 9 as 8 is to x. Okay, corresponding sides, so I'm starting with this triangle in the numerator, so I need to keep it in the numerator in both ratios. Now I can do my little cross multiply divide is kind of the sneaky trick here to figure that out. 8 times 9 is 72. 72. 6 times x is 6x. And I know what you're thinking. Opposite of multiply by 6 is divide by 6. I'm going to divide both sides by 6. And I'm left with... What am I left with, folks? Hey, there we go. 12 is equal to x. All right. Any questions?